Next, we will see the examples or problems of Routh criterion. Determine the stability of the systems represented by the following characteristic equations. If the system is found to be unstable, determine the number of roots of the characteristic equations in the right half of S-plane. That is the question. The characteristic equation is given. So you need to find whether it is stable or not. If it is not stable, you have to find whether it is stable or not using Routh criterion, stability criterion. If it is not stable, what you need to do is you need to determine the number of roots of the characteristic equations in the right half of S-plane. Now here you can see examples. We'll see one by one. First example, we'll take s raised to 5, s4, 24s cube plus 48s square minus 25s minus 5 is equal to 0. Yes, so here what you need to do is the highest order is fifth order equations. So you have to start with S5, then S4, then other things. This representation is for reference purpose only. Next S3, S2, then S1, S0, S raised to 0. Till S raised to 0 you have to make the rows. Now the coefficient of S5 you have to take first, then coefficient of S3 that is 24, then coefficient of S that is minus 25, that will be the first row. For S4, the coefficient of S4 is 1, that is the first element. Then coefficient of S square, that is 48. Then the next is the constant, that is minus 5. Now once you form the first two rows, then you have to find the next two rows by using the Routh stability criterion formulas or its rules. That means starting from here, 1 into 24 minus 1 into 48 divided by 1. When you're calculating it, you will get a minus 24. Okay. Now the second element is calculated with the this row is calculated with the 1 into 1 into not here, this way it is first 1 into minus 25, 1 into minus 25 minus 1 into minus 5 divided by this one. So you are getting it as minus 20. And last element, so here only two element you got it. The last element become 0 because there is no further processing after this. So this element is become 0. Now only two element. Now the s raised to 2 rows is obtained by considering the above two rows. So it is obtaining like this: minus 24 into 48. The flow is in the same way: minus 28 into 48 minus 1 into minus 20. So you are getting it divided by minus 24. So you are getting 47.16. The second element is obtained by this two element with the this two element with the minus 5 and 0. So here how it is done is minus 24 into minus 5, minus 24 into minus 5, 1 into 0, 1 into 0 divided by minus 24. So we are getting minus 5. Now next element, that is s raised to 1, is obtained by considering these two rows. So here 47.16 into 20, 47.6 into 20 minus 20 into minus 24 into minus 5 divided by 47.16, that is 22.54. After that there is no further rows here and further elements here. So next element is 0. Now s raised to 0 element is obtained by considering the previous two rows. So here you can see that here it is 0. So you will get it as minus 22.54 into minus 5. Okay, minus like this, minus 22.54 into minus 5 minus 47.16, here it is 0 by minus 22.54. So when you are calculating it, minus 5. Now it is over. Now you need to see the elements in first column. So here these two are positive, here you are getting minus, here positive, here minus, here minus. So certainly all the elements in the first columns are not positive. So you can definitely tell that it is unstable. Now what is the next step? You need to see how many sign changes. Now you can see that here there is no sign change. When you are comparing this, here it is positive, here it is negative. So one sign change. Then here it is negative, here it is positive. That means second sign change. Here it is positive, here it is negative. This is third change. Here it is negative and here is negative. There is no sign change. So there are 3 sign changes. That indicates that there are 3 roots or 3 poles on the right half of S-plane and the system is unstable. There are 3 sign changes, so that indicates like that. So otherwise also, but in our initial the previous class, we in a normal way of examining, you can see that all s raised to 5, s raised to 4, s raised to 3, s raised to 2, all the elements are there, but the coefficients all are not positive. So you can say that it is unstable. Here we did all the coefficients of the characteristic equation real and have the same sign. Here we said here all the coefficients of the characteristic equation real and have the same sign. Now none of the coefficients should be 0. So we did some problem also related to that. From that criteria only you can understand that it is unstable. But here one more additional facility you are getting, that how many poles are located right half of S-plane, that we can find using this root stability criterion. Now we'll see the next problem, that is s raised to 4, 2s raised to 3, 10s square, 8s plus 3 is equal to 0. So the highest order is S4. So S4, S3, S2, S1, S0. S4 coefficient, that is 1 and 1 you have to put it here. Then next to next coefficient S square, that is 10. Then next to next, that is 3. And here SQ coefficient 2. Then you can see that next to next, that is 8. Next to net, that is not there. That is why it is empty, or you can put 0 also. You can consider. Now the same method. The method is, you already understand that you are going from down to top, then top to down. That is the higher order. So here 2 into 10 minus 1 into 8 divided by 2. That is the first element. Now the second element is obtained by 1 into, from bottom you have to go to top. 2 into 3 minus 1 into 0 divided by 2. So you are getting 3. Now the S1 elements you can find by considering the above two rows. Now here 6 into 8 minus 2 into 3 divided by 6, that is here. Then you are getting 7. Then yes, 6 into 8 2 into 6 into 8 6 into 8 minus 2 into 3 equal to 7. Now next is 0, because there is no element. That is a little doubt. 6 into, here it is 0. 2 into 0, 2 into 0. 6 into 0, 2 into 0. So it is becomes 0. Now s raised to 0 elements. This is not required. S raised to 0, that is you have to consider previous to 7 into 3 minus 6 into 0 divided by 7, it is equal to 3. Now when you are observing the elements in the first column, all the elements are positive. So all the elements in the root array are positive. So the system is stable. Our normal checking also, you can see that all the coefficient is having same sign. So there also, that way also you can say that the system is stable. Now when you are coming to the third example, that is s raised to 4 plus 4s raised to 3 plus s square plus 8s plus 1. The order is 4. So s raised to 4, s raised to 3, s raised to 2, s raised to 1 and s raised to 0. Now you have to put the coefficient s raised to 4, then next to next, that is 1, next to rest, that is again 1, then for s raised to 3, 4, then next to next 8, next to next is 0, we are empty. The same way you have to form 4 into 1 minus 1 into 8 divided by 4, that is minus 1. Next element is obtained by 4 into 1 minus 1 into 0 divided by 4, that is 1. Here the next element is obtained by here s raised to 1 is obtained by considering the previous two table. Now this is minus 1 into here minus 1 into 8 minus 4 into 1 divided by minus 1, you are getting this. Then about 2 should be considered with the next, there all are 0, so you are getting 0 here. Then this you are getting it by 12 into 1 minus 1 into 0 divided by 12, you are getting it as 1. Now when you are observing it, you can see that there are sign change in the first column. How many sign change? Here these two have same sign. From here to here, one sign change. From here to here, second sign change. So there are two sign changes. There are two sign changes. in the coefficient of the first column of the root array. So there are two roots of the characteristic equations are on the right half of S10 and the system is unstable. Next is next example, the same way sy s4, this is the example, and you can see that it is the order of 5. So s5, s4, s3, s2, s1, this is for reference. The coefficient of s5 1, then next to next 6, next to next 18, next to next is 0, then s4 coefficient 1, next to next 12, next to next 6. So you can see that all the elements are same sign. Now you can calculate 1 into 6 minus 1 into 12 divided by 1, that is minus 6. Okay, yeah, 1 into 6 minus 1 into 12 divided by 1, it is minus 6. That is first element. Then 1 into 18 minus 1 into 6, okay, divided by 1, you're getting 12. Next is, you know that 1 into, next it cannot go, so it is 0. There directly you put 0, that is enough. Next, these elements are obtained by considering previous row, that is minus 6 into 12 minus 1 into 12 divided by minus 6, you are getting 14. Then minus 6 into 6 minus 1 into 0 divided by minus 6, you are getting 6. Okay, further there is no further, this will this two, further there won't be. Okay, now that is happened here. Then this is obtained by 14 into 12 minus 6 into 6 divided by 14, so you're getting this. Okay, these two rows. Then this two row here, both are 0, there is next is 0. Then last element is obtained by 14 into 6 minus 14 into 0 divided by 56. When you're observing, even though all the elements in the characteristic equations are positive, but you can see that there are sign changes in the first column of the root array. So there are how many sign changes? From here, these two are same sign, but here from here to here, positive to negative. Then from negative to positive, there are two sign changes. So two roots of the characterizations in the right half of S plane. So the system is unstable. Similarly, when you are observing to the next problem, first you go through the problem, understand it, then you take your own time and try to understand the concept. See here, as you can see that this is S6, the order is 6, so S6 plus 2, S5 plus 8, S raised to 4, 15, S raised to 3, plus 20, S raised to square, plus 16, S plus 16 is equal to 0. So the same way, S6, yeah, you can see the S6 row, first one S6, then S5, then S4, then S3, S2, S1 and S0. So till S0 you need to do. Now you have to arrange the first row, the S6 coefficient, next to next coefficient for S, that is S raised to 4, that is 8, next to 8, that is S raised to, that is 20, then next to 8, that is 16, and S raised to 5 you have to start, that is 2, then next to next, that is S raised to 3, that is 15. Next to next rate, that is S, that is 16. Then you are getting a 0 here. So the same procedure you are doing it. You are getting here 0.5, then 12, then 16. And if you go to the next, here you are getting minus 33, then 48. Here you are getting minus 11.2 minus plus 11.27, 16. When you are coming here again, it is minus 1.16 here, 16. Now when you are observing, you can see that the elements in the first columns are not in the same sign. Not all are positive. Okay, if it is positive, then you can say that it is stable. When you are observing it here, all are positive. But if you go from here there to here, one sign change. From here, next sign change. From here to here, another sign change. From here to here, another sign change. So there are 4 sign changes in the elements of the first column. So there are 4 roots of the characteristic equations are there in right half of S plane. So this is the things you should understand. Now, suppose you are getting an expression like this. Yes. Yeah, there is a problem. So here, is the system shown in 541 is stable or not? You need to find whether it is stable or not. Now, these two blocks can be multiplied and you can make a single block. So it is like this. You are getting, and yes, you are getting like this. Yes, a single block with 10 divided by S into S minus 1 into 2S plus 1. Then you are having the C of S. From there you are drawing back to here. So this is minus, here plus, negative feedback. This is R of S. Okay, now you need to find C of S divided by R of S, that is equal to you know that this is a feedback system. So this can be reduced into single block, or the transfer function is obtained by G of S divided by 1 plus G of S plus H of S. That is G of, the formula is already we come across, G of S divided by 1 plus G of S into H of S. Okay, G of S into H of S. So then you will get it as G of S is nothing but 10 divided by S into S minus 1 into 2S minus 1 divided by 1 plus G of S into H of S. H of S is here 1. There is no block here, it is considered as 1. So you are getting it as 10 divided by S into S minus 1 into 2S minus 1. And when you are rearranging this and when you are cancelling, so this will be equal to, so here this will be equal to, when you are rearranging this, so here it will become S into S minus 1 into 2S minus 1 plus 10 divided by S into S minus 1 into 2S minus 1. This is the denominator. Over that, 10 divided by s into s minus 1 into 2s minus 1. So this and this will be cancelled. So 10 divided by s into s minus 1, 2s minus 1 plus 10 is the transfer functions. This 2 will be cancelled. So transfer function 10 divided by s into s minus 1, 2s minus 1 plus 10. So this will be the denominator term that equating to 0. That is the characteristic equation. So you are getting it as here when you are doing like that, s into s minus 1 plus 2s plus 3 plus 0 is equal to 0. When you are expanding this, multiplying 2s raised to 3 plus s square minus 3s plus 10 is equal to 0. Now you have to do the same way. The highest is s raised to 3, then s2, s3, s1. Here 2 you have to put first, then next is minus 3, then after that nothing. Then for s square it is 1, and after that 10. So what did you do? 1 into minus 3 minus 2 into 10 divided by 1, and that is 23. Then 1 into, here there is terms are 0, so it becomes 0. Now next x raised to 0 obtained by minus 23 into 10, 23 into 10 minus 1 into 0 divided by minus 23 is 10. So when you are observing it, first of all elements are not positive. Then there is two sign changes, one from here to here. Now from here to there are two sign changes. The first column of the array. Hence, there are two roots of the characteristic equations in the right half of S plane.